Hello my dear students, good afternoon. Now we will discuss about the properties of alcohols. So first we will discuss about physical properties of alcohols and then we will discuss about chemical properties of alcohols. Okay, so in physical properties, first physical state we will discuss. Physical state, okay. In physical state what we will discuss, like methanol actually, CH3OH, and it's a actually gas, poisonous gas, but easily liquefiable. Why easily liquefiable? These alcohols has ability to form hydrogen bonding. Ability to form what's a H bonding. So they have extra strength due to hydrogen bond and extra attractive forces due to hydrogen bond. So that these alcohols mainly exist as liquids actually. Okay, alcohols exist in what physical state? Liquid state due to extra bonding. What is that extra intermolecular forces? What is that extra intermolecular forces called? Hydrogen bond. See, this is one alcohol actually, ROH, ROH, ROH. So hydrogen of this alcohol and oxygen of another alcohol, between them you have a hydrogen bond like this. So hydrogen bond you have between two alcohols. Hydrogen bond is present between these two alcohols again. Hydrogen of this alcohol and oxygen of another like this. So hydrogen bonding is present in alcohols. Got it clearly? So what you have to understand, due to hydrogen bond, due to hydrogen bond, alcohols soluble in water. You know, ethanol soluble in water or not? Yes. Ethyl alcohol soluble in water. We will mix now. That one. Okay. So due to H bond, alcohols soluble in water. Okay. But as number of carbons increases, then solubility, what happens, do you know? Solubility of alcohols decreases as number of carbons increases. Why happens like that? Because as number of carbons increases, then hydrophobic nature increases. Hydrophobic nature. See, this carbon chain is hydrophobic. Suppose here 2 carbons you have and OH, and 3 carbons you have and you have OH, and 4 carbons you have 1, 2, 3, 4 and you have OH. And if you see what this 2 carbons is called hydrophobic. Carbon chain is what? Hydrophobic. What is the meaning of hydrophobic? Water hating. Hydro means water. Phobic means phobia. Phobia means fear. Carbon chain is hydrophobic. But this OH group you have now, this is hydrophilic. Hydrophilic actually. So this with 2 carbons and with 1 carbon actually more soluble in water. Getting what I'm saying? COH means methanol actually. CH3OH. It is ethanol. CH3CH2OH like that. Okay. So as number of carbons increases and this hydrophobic nature increases, because number of carbons increases, hydrophobic nature increases. Because number of carbons increases, their carbon chain is non-polar, but water is polar. Non-polar cannot soluble in water. No? Understand what I'm saying? Carbon chain is a non-polar actually. So non-polar substances cannot be soluble actually in water. You know that, like dissolve like fluid, means polar dissolve in polar, non-polar dissolve in non-polar. So as number of carbons increases, non-polarity increases. This OH bond is polar actually. This OH bond is there, no, everywhere. This OH bond is polar bond. Even CO bond is polar bond. So that's why as number of carbons increases, solubility in water decreases. As number of carbons increases, solubility in organic solvents increases. Suppose in benzene, who can soluble more means this which has more number of carbons. So with 4 number of carbons, this alcohol can soluble in inorganic solvents more effectively. But coming to this first one, this methanol soluble in water. Understanding? So what I said? Solubility in water. This is the order. Greater than I written no. So this has greater than this. This has greater than this. What? Solubility. Solubility in what? Water. Solubility in water. Same. I repeat. Solubility in CCl4. Solubility in benzene means ulta order. Please remember this. Because as number of carbons increases, hydrophobic nature increases. Okay. So this is very important. And one more thing. Hydrogen bonds are present, I told no. So ability to form H bond is primary alcohol. Primary alcohol has more ability to form H bond to form hydrogen bond. Which has more ability? This primary has more ability to form H bond, then secondary alcohol, then tertiary alcohol. Who has great ability to form H bond is primary. Because as number of alkyl groups increases, that steric hindrance is there. So that OH bonds cannot come closer because repulsion takes place now due to more number of alkyl groups. More number of alkyl groups present in primary or secondary or tertiary? Tertiary. Understanding? Listen carefully. This is very important. Haloalkane, haloarene is over. Okay. And now alcohol is almost completed. So remaining 3 chapters only there in organic. But organic you will have 10 questions. Only from second year. So listen carefully. You can understand. Slowly understand. Not a problem. Okay. But you have to understand. So solubility in water, what happens? I was given. And as number of carbons increases, solubility decreases. And to form H bond, what happens here? To form hydrogen bond, who can form hydrogen bond fast? Primary alcohols or secondary alcohols or tertiary alcohols? Who can form hydrogen bond fast means primary alcohols forms H bond faster. Okay, so next the most important thing is solubility in isomeric alcohols. In isomeric alcohols, who can soluble fast? Suppose I am taking this CH3C, CH3 and CH3OH. You know what is this? Tertiary alcohol. Tertiary alcohol. And secondary alcohol, CH3 and CH3 and OH and CH3. It is secondary alcohol. Okay. Next, secondary alcohol after I will write this one. You know, isobutyl alcohol. Tertiary butyl alcohol, secondary butyl alcohol. Sorry, secondary no. Secondary butyl. So this one CH3, CH2, CH3. Sorry. This one. And this one CH3, or here you can write CH3 CH actually, CH CH3 CHOH and CH3 and CH2 and CH2 and CH2OH. This is primary alcohol. Among these, who soluble more? I was given here tertiary alcohol soluble more. Sir, you only said no, sir. Primary alcohols can form H bond easily, but here hydrophobic nature is more, and so that hydrogen bond ability is less. So in primary alcohols with number of carbons less, then hydrogen bonding is more actually. So this is very very important. So to soluble more, number of carbons should be less and they should be primary. But here then why tertiary, sir? Here also number of carbons are more, no, but surface area is less for tertiary. Please note this point everyone. So tertiary alcohols has less surface area. Certainly they can easily soluble in water. Okay, surface area if they occupy more, they cannot soluble in water easily. So who can soluble in water more means tertiary alcohol, secondary alcohol and primary alcohol. Okay. So this is about what physical state, and physical state is liquid. Why? What is the reason? Hydrogen bond. Even for solubility, the reason is H bonding itself. So why alcohol soluble in water? Because of this OH bond hydrophilic nature. Hydrophilic means what is the meaning? Water liking. Hydro means water. Philic means loving. Water loving. This OH group. Certainly solubility in water increases. Getting what I am saying? So solubility in water, why increases? They have ability to form H bond. Here also H bond is there. Here also H bond is there. Here also H bond is there. But here even we only said surface area is more, then H bonding ability is less. But H bonding ability is less, but surface area is very less here as branching is more. So if surface area is less and there is ability to do soluble in water easily. Okay. So here this soluble in water, this soluble in water. But what is the difference? This slightly more soluble. Tertiary alcohol, tertiary butyl alcohol, this secondary butyl alcohol, and this is primary butyl alcohol. Difference you must know, everyone. Is it clear? There is no big difference in H bonding formation actually. Slightly primary is having more, but surface area is less. That's why solubility of tertiary alcohols is more. Okay. In isomeric alcohols, what is the meaning of isomeric? Having same formula. Tertiary butanol, secondary butanol, primary butanol. All have same or not? Okay. Even isobutanol you have, means one more carbon will come here. So less branching, no? Even secondary isobutyl alcohol has more solubility. That also you mentioned please everyone. So tertiary alcohols after isobutyl alcohol, isobutyl after secondary, secondary after primary. So this is about the solubility. Next we have to discuss about the boiling point. Whose boiling point? Boiling point of alcohols. Okay. So alcohols has less boiling point or more boiling point. So for everything here one reason. What is that? Intermolecular forces. If intermolecular forces increases, then boiling point also increases. Please remember what I am saying, all those things you have to remember. So very important. So I told you remember or not in previous, as branching increases, boiling point decreases. Do you remember? As branching increases, boiling point decreases actually. Okay. So you have to remember all those things. As intermolecular forces increases, then also boiling point what happen? Decreases. Do you remember that? As branching increases, boiling point decreases. Okay. So all these things, intermolecular force increases. I told you this, So next is boiling point. So as intermolecular forces of attraction increases, then boiling point also increases. Okay. As molecular weight increases, boiling point increases. Remember all these things. As branching increases, then boiling point also increases. Why? Molecular weight increases, molecular weight increases, boiling point increases. But as branching increases, what happened? This surface area decreases. As branching increases, surface area decreases. Okay, so that boiling point increases. This is one of the important thing you must know. Okay. So what I am saying here, 3 points for understanding boiling point. What I said? As intermolecular force of attraction. Do you remember intermolecular force of attraction means? Van der Waals forces. Okay, Van der Waals forces are what? ion dipole forces, okay, dipole forces, dipole induced dipole forces, okay, London dispersive forces, and hydrogen bond. So here alcohols has what intermolecular forces means it has H bond. Due to H bond they have extra intermolecular attractive forces. Certainly boiling point increases. Okay, so as intermolecular force of attraction increases, then boiling point increases. As molecular weight increases, boiling point increases. Because molecular weight increases means more weight, so more temperature is required to heat that one, right? So boiling point means everybody have idea, no? The temperature at which vapor pressure is equal to atmospheric pressure. Or few people will say boiling point means the temperature at which boiling starts. That is actually not correct definition. Boiling point means in elevation and boiling point solutions chapter I was explained. So boiling point means the temperature at which vapor pressure is equal to atmospheric pressure. So these are very important. So as branching increases, surface area decreases and boiling point increases. Very important. Now you only can say, see, I will give one by one examples. Okay, see, alcohols and ethers, CH3, CH2OH, and alcohol it is CH3OCH3. Okay, alcohols and ethers are what they are, functional group isomers actually. What isomers these two? Functional group isomers. What is this? Alcohol. Alcohols and ether. I was given one example, but which has same formula by consisting of OH group and ROR. They are functional group isomers. So alcohols and ethers are functional group isomers, but still the alcohol has more boiling point. So if you see ethanol and this dimethyl ether, among these who have more boiling point means boiling point of ethanol is more. Why this boiling point of ethanol is more? What is the reason? Yes, due to H bond, hydrogen bond. This is very important. Okay, not only this, comparative means with this who have similar molecular weight. Okay, so even the molecular weight is similar with this. Okay, then that alcohol is more boiling point. What is the reason behind it? Because alcohols has ability to form H bond, hydrogen bond. This is very important for us. Got it, sir, clearly? So what I given here, alcohol has more what? Boiling point. Due to what is the reason? H bond. But ethers have less comparatively. Ethers has less boiling point comparatively these alcohols. What is the reason behind it? Ability to form H bonding is less. Getting what I am saying? So even they have same molecular weight because molecular formula is same, but alcohols have more boiling point. So this is very important. Then next another example I am giving now. So here I am comparing this alcohol with the hydrocarbon as well as some aldehydes and ketones which have almost similar molecular weight. Okay. So which has more boiling point means, now only I am telling, alcohols have more boiling point even than some hydrocarbons or else haloalkanes or else some aldehydes and ketones. Okay, even than ether. Previously I was given alcohols has more boiling point if you compare those which has almost similar molecular weight. Those means who? If you compare alcohols, ethers, aldehydes and ketones, haloalkanes and then hydrocarbons, if you compare among them who have more boiling point means alcohol has more boiling point. If you compare those 5 kind of molecules which have almost similar molecular weight. Okay, so if you see here 3 carbons actually, its molecular weight of ethanol is 46 and this propane 12, 12, 12, 36, 36, right? 36 plus 8, correct sir? Correct or no? So here it is 44, 36 and 8, 8 hydrogens na? So 36 plus 8, so 44 is the molecular weight. Okay, so 44 grams. And if you compare this CH3 and CH2, CH3 Cl, suppose CH3 CHO, otherwise CH3 CHO, double bond O, if you compare this, okay, 2 carbons and 24 and 16 and 4, okay, this also has 44 weight, right? 2 carbons, okay, 2 carbons, 24 and 16 oxygen and 4 hydrogens, okay, 44. Even if you compare these, who have more, if you are taking this 1 and this is 2 and this is 3, who has more boiling point, means this one has more boiling point, okay, than ether. However, also same, ether if I want, I will take diethyl ether, okay. So if I take this first and then ether, then aldehyde actually, okay, because ether has same, sorry, here if you take one more ether, that is CH3O CH3 if you take, and this is number 4 if I consider, okay, one has more than 4, then because it also has 46 molecular weight. And this one, next CH3CHO, aldehyde, next this 3, then least is 2. Why sir? Why boiling point of this alcohol is more? Because alcohol has extra strength, that is hydrogen bond. Then okay sir, this is 44 and this is 44. But why this aldehyde has more boiling point than in this normal hydrocarbon? Means yes, this CO bond is polar. Certainly that dipole-dipole interactions are there. So some extra van der Waals forces are there or not? That's why 3. Then 3, why this has more sir? Because this oxygen is saturated. Certainly this has somewhat more free and more lone pairs. Okay, certainly this oxygen has more interactions than this oxygen, because this is double bonded and this is single bonded. So first alcohol, then ether, fourth one is ether, no? Then third, then this. Got it? So what I am concluding finally, if you compare alcohols, hydrocarbons, ethers or aldehydes and ketones which have almost similar molecular weight, among them alcohols has more boiling point. Why alcohols has more boiling point? What is the reason? Due to H bonding. Due to what bonding? Hydrogen bond. This one has more boiling point because of hydrogen bond. Not between these two. This OH has ability to form hydrogen bond. H bond. Got it clearly? So alcohols, why has more boiling points than ethers? What is the reason behind it? Due to H bonding. Hydrogen bonding is the reason. Okay. So as I said in previous, now as branching increases, surface area decreases, boiling point increases. And as I told, the second point, molecular weight increases, boiling point also increases. Suppose if I compare this in CH3OH and CH3CH2OH and CH3CH2CH2OH, all are alcohols. Even the ability to form H bonding is decreases, but molecular weight increases. Difference understanding? So the boiling point is in this manner. So molecular weight increases, boiling point also increases. Sir, you only said no sir, intermolecular forces here more. So here it should have more. What more? Boiling point. But here 1 point okay, but molecular weight also you have to consider. No, here I said as molecular weight increases, boiling point increases. Okay, more interactions but less weight. Here also interactions are there but little bit less than this. So here two are there, intermolecular forces are there but somewhat less comparatively, but there now. And moreover here molecular weight is more actually. Okay, So these all things are very important for us. So as molecular weight increased, so boiling point increased. And next, third, as branching increases, boiling point increases, surface area decreases. As I said, this tertiary alcohols has more boiling point than secondary alcohols than this primary alcohols. So because as branching increases, at boiling point, as branching increases, the boiling point decreases. I'm confusing here, sorry. As branching increases, surface area decreases and boiling point decreased. Here I said the same thing, no? Sorry for that. And please remember this one, everyone, please. As branching increases, surface area decreases and boiling point decreases. Maybe few people were struck there, I think so, but please remember everyone, this one correct. As branching increases, surface area decreases and boiling point decreases is correct. Please note this everyone, because as surface area is decreased, intermolecular attractive forces are less. Certainly boiling will be easy. So tertiary alcohols have less boiling point, but solubility tertiary alcohols are more. But here or tertiary alcohols has less boiling point due to branching. See here, tertiary butanol, if I am considering tertiary butanol, CH3C and CH3 and CH3OH. Tertiary butanol has less boiling point than this secondary, like this, or isobutyl alcohol, CH3, CH and CH2OH, and then this one less branching, CH3, CH2 and CHOH and CH3 secondary. Then this primary has more, CH3, CH2 and CH2, CH2OH. What I written here, understood? So tertiary butyl alcohol, this tertiary butyl alcohol has less surface area, so less boiling point. Please remember this one. Okay, so as branching increases, surface area decreases. Surface area decreases, between two molecules gap increase. Certainly attractions decrease. So boiling will be easy. So tertiary butyl alcohol has more than tertiary alcohols has less boiling point than secondary alcohols. Secondary alcohols has less boiling point than primary alcohols. So this is a very clear point. As branching increases, surface area decreases, boiling point decreases is correct point. Okay, so as molecular weight increases, boiling point increases. As intermolecular force of attraction increases, boiling point increases. Now what I said is absolutely correct. No, okay, nothing wrong here. So everything is correct. Hope you understood all these things. So tertiary butanol has less boiling point or more boiling point. Tertiary butanol has less boiling point because surface area is less. That's it. This is the final conclusion. I hope now you don't have any confusion in this. Here you remember, this is tertiary, this is isobutyl. Do you remember isobutyl alcohol? Isobutyl like that. Okay, same you can use for neopentyl. Neo means come for 5 carbons. Okay, so neopentyl, tertiary and isopentyl. If you compare like that, same story. As branching increases, boiling point decreases. This is final point. Okay, next we have to enter into what chemical properties of alcohols. Even see, I was given previously that about ethanol and methanol. Okay, methanol has less boiling point or more boiling point. Methanol has less boiling point. It is around 68 something. Ethanol is 78 something. Methanol is a poisonous gas. Okay, and ethanol is a fruity smell actually. Ethanol. Okay, ethanol easily soluble in water. That is also dangerous. But methanol even is a small quantity if you inhale that causes blindness. Methanol, but ethanol is not that much danger. So if I say that is different, don't take differently. Ethanol is also highly dangerous. I'm telling, but comparatively, and that methanol is highly poisonous. Means immediate effect you will have. Getting what I'm saying? So methanol, if you inhale more, it causes death also. Getting what I'm saying? So it's a very important about the physical properties. Next we have to discuss about some chemical properties. This chemical properties, two types in alcohols. Actually alcohol has two types of bonds actually. Two types of bonds. Okay. Suppose here you have some R group. See, this is one kind of bond, CO bond, and you have one more kind of bond, that is OH bond. Okay, so here reactions involving OH bond cleavage you have, OH bond cleavage you have, and reactions involving CO bond cleavage also you have. Reactions involving OH bond cleavage and reactions involving CO bond cleavage, you have two types of chemical properties you have in alcohols. This is very important. Okay, so alcohols involve in how many types of reactions? Two types. Reactions involving in OH bond cleavage and reactions involving in CO bond cleavage actually. So first we have to discuss about reactions involving OH bond cleavage, because two polar bonds are there. OH bond is one polar because H plus and O minus is possible, and here in CO bond cleavage this is O minus and C plus, two types of bonds are there. In OH bond cleavage H plus and O minus. So OH bond is polar and CO bond also polar. But reactions involving OH bond cleavage, order of reactivity if you see, primary alcohols are more reactive for OH bond cleavage than secondary alcohols than its tertiary alcohol. Okay, but reactions involving CO bond cleavage reverse to this, because carbon positive here in CO bond cleavage. Which carbocation is more stable? Tell me. Tertiary carbocation is more stable or not? So reactions involving CO bond cleavage is ulta. That means primary alcohol are less reactive than secondary alcohol than less reactive. Secondary alcohol is less reactive than tertiary alcohol. Reason understood? So alcohols involving two types of chemical reactions, chemical properties. One is reactions involving OH bond cleavage, reactions involving CO bond cleavage. If reactions involving OH bond cleavage, if you see, the primary alcohols are more reactive. Primary alcohols are more reactive towards OH bond cleavage. Okay, reason I will tell you for that. And reactions involving CO bond cleavage, if you see, tertiary alcohols are more reactive towards CO bond cleavage. I told you here already reason, because in CO bond cleavage, oxygen gets minus and carbon gets positive. Which carbocation is more stable? Carbon positive means tertiary carbocation is more stable or not? That's why tertiary alcohols are more reactive for CO bond cleavage. But for OH bond cleavage, primary alcohols are more reactive. So let's see now one by one. So we will discuss about reactions involving OH bond cleavage. See how the OH bond cleavage happens. CH3OH and CH3 CH2OH and CH3 and CH3OH. If you see, among these for OH bond cleavage, this is more reactive. Why? What is the reason? This hydrogen have to go as H plus. Means this bond must migrate towards oxygen. Listen carefully. Hydrogen have to go in the form of H plus, right? So this bond, this sigma bond must move towards oxygen. But the same thing must happen here. So this hydrogen we have to remove as H plus, right? That means this bond must come towards oxygen. But what happened here? This methyl is donating electron and this methyl is donating electron. So this, from this oxygen, this on oxygen, electron density increasing so that H plus cannot come out easily. I repeat, this oxygen must be less electron denser. Means here the groups what you have must be electron withdrawing groups, but here electron donating groups are there. So if electron donating groups are there at this carbon, so these are donating already, then why this bond will come towards oxygen? When this bonded electrons will move towards oxygen, remember? So this and this, if electron withdrawing, then this bond will move towards oxygen. Certainly H plus can come out easily. Getting what I am saying? So what I am trying to tell you here, if electron withdrawing groups increases, then OH bond cleavage strength also increases. This is very, very important. If electron donating groups increases, then this OH bond cleavage strength means won't happen. Reactivity will become less. So this is very, very, very important for us. So electron withdrawing groups increases, OH bond cleavage also increases. Understanding? So what required to go as H plus? So to remove this hydrogen as H plus, this oxygen should be less electron denser. But in this case what happened? This oxygen become more electron denser. This methyl donating and this bond have to come towards oxygen. Means on oxygen electron density is more increasing or not? So H plus cannot come out easily in this case of secondary. Even if I compare tertiary has less even than secondary. Getting what I am saying? But here only one methyl is donating, CH3OH. But here what happened? This CH2 is donating, this carbon also donating. So this bond cannot come towards oxygen easily here. Okay, so that's why when you compare, methanol is more reactive than this. This is more reactive than secondary. Secondary is more reactive than tertiary for OH bond cleavage. So very, very important. See now, I will give you one more example. Cl CH2OH and CH3OH. Who is more reactive towards OH bond cleavage? OH bond cleavage reactivity you have to say. See, OH bond cleavage reactivity is more for ClCH2OH. Do you know what is the reason? So this chlorine is electron withdrawing group. Certainly this will withdraws more. Certainly this will withdraws more. Certainly this will come towards oxygen so that H plus can come out easily. So what I am trying to tell you here, see, if electron withdrawing groups, do you know what we call them? Minus I group. So if minus I group is there, our number of minus I groups increases, then OH bond cleavage also increases. That means OH bond cleavage reactivity will increase. When the OH bond cleavage reactivity increase, when the minus I groups increases. So what you can understand here, minus I groups if there, H plus can go easily. So what is the meaning of donation of H plus or removal of H plus? Acidic character. What character that is called? Acidic character. So what is our final conclusion here? I am writing final conclusion. In alcohols, in alcohols as minus I groups increases, then one more thing, acidic character also, what character increases? Acidic character also increases in alcohols as minus I groups increases, acidic character increases. Please remember this one. Why? I was given very clearly here. If chlorine is there, this is withdrawing electron towards it. Certainly on oxygen electron density what happening? Decreasing. Certainly this sigma bond will try to move towards oxygen. Understanding what I am saying? Sir, I have 100 rupees here. So from backside, my friend is donating 1000 rupees. Then I won't think about this 100 rupees. To lose this, it's very simple. So I have 100 rupees. Some people is trying to take 200 rupees from me. Then what happens? This will attract towards me. Difference understanding? The same thing. Here it is taking. So this oxygen will think about this bond. 100 rupees means this bond. So that here what you have, it will remove. So I will throw that person. That person means who? H plus. Taking clearly. Here one person is there. Here 100 rupees is there. Somebody taking money from me. So I will think about this 100 rupees. Certainly that person will go. If somebody is donating 1000, then I won't think about this bond. 100 rupees means bond, not hydrogen. Here H plus, some person is there. So I won't think about this 100 rupees because somebody is donating 1000 rupees to me. What 1000 rupees understood? 1000 rupees is more donor. Here this bond. Oxygen is me. Okay. 100 rupees is this bond. And some person means H plus. Okay. Understand? So very simple. If I have a donor, I won't think about this 100 rupees. If I have some withdrawing group, means somebody is taking money from me, then I will think about this 100 rupees. 100 rupees means this bond. This bond. Got it clearly? So very simple. So if electron withdrawing groups increases, that means minus I groups increases. OH bond cleavage increases. OH bond cleavage increases. That means H plus can easily come out. So OH bond can cleave easily. Certainly acidic character increases. This is the most important point. We will continue freshly all these points. All these points means as a chemical reactions. So in your mind, don't feel bored. Last and final point I am telling you, as minus I groups increases in alcohols, acidic character increases. But however, in general, alcohols are less acidic even than water. You remember for today's class what I said. Finally, alcohols are less acidic. I told no, alcohols has alkyl group, but water no donor. But in alcohols, alkyl group is donor. Certainly, what I said, if donating nature increases, acidic nature decreases. Remember this one. Because H plus have to go, so electrons must come towards oxygen. So when electrons can come towards oxygen, when electron withdrawing groups are present. These all things I am saying, a few people can understand first time itself. They may feel bored, but I am talking about remaining people. So they may understand second time or third time. So these are very very important. Please remember all these things. So finally, electron donating groups increases, acidic character decreases. That means reactivity towards OH bond cleavage decreases. If electron withdrawing groups means what? Minus I groups. Minus I groups means everybody have idea, no? So if electron withdrawing groups are more, then OH bond can easily cleave. That means H plus can easily come out. H plus can easily come out means acidic character is more. Thank you very much. We will continue these chemical properties in our next class. Okay, thank you.